Hey guys, so today we'll look at a program to display the sizes of various data types. Now we already know that you have different data types like int, float, char, long, double. All these are different data types and all these have different sizes associated along with it. Like int can be 4 bytes or 2 bytes depending on what operating system you have. Char will be 1 byte and double will be 8 bytes and so on. So how do we display this size 8, 2, 4, 1? For that we have a operator known as the sizeof operator. The sizeof operator will take either the data type like an int, or it can take a variable name which is associated with a data type. Either the data type or the variable name it can take as an input and it will give out the size. So usually when you print out size, you will be printing it in a number, and number is associated with a %d as the format specifier. But %d is a signed integer. It can take a negative sign as well as a positive sign. Sizeof will display in %d also, but sizeof usually gives the size, which is never going to have a sign associated with it. It's never going to be negative, it's always going to be positive. So even if you put it in %d, you will get a couple of warnings. After that, your output will be displayed. But it is preferable to write it in the actual format specifier, which is %lu. This is the format specifier for an unsigned int or an unsigned long, and it will give but the output will always be in unsigned, meaning it is not going to have a sign associated with it. Having a positive sign is not unsigned, positive sign is also a sign. This will be devoid of a sign. So preferably when you give the sizeof operator, use %lu right in the printf statement when you put the format specifier. So there are many ways you can do it. You can do it in this way where you can write int a, float b, char c, and let's say long d and double e. You can declare a couple of variables like this, and you can start printing by using the sizeof operator. Like you can write printf size of a, and you can go ahead and write %lu, and in the place where you have to display the value, you can write the operator size of a. This will display that size of a is equal to 2 bytes or 4 bytes depending on what operating system you have. You can do the same thing for b. You can do printf size of b, or if you want to print the value, if you are giving a value and you want to print the value, you can go ahead and write size of %f. Size of %f is equal to %lu, where you can first print the value of b and second print the value size of b. You can do this. Another way you can go ahead with printing the sizes. So here I have the first printf statement, I have just printed out the size. Second printf statement, I have printed out the value as well as the size. But for this printf statement, make sure that you are giving a value to it. Like you have to give a value during initialization, or you can use a scanf statement and just write 12.5. So it will say size of 12.5 is equal to 4 bytes. It will give that value. Now the other way you can go ahead with printing the size is printf, and you can give size of I'm not going to write the value because here I'm not going to associate it with a variable. So you can just write size of int is equal to %lu and then write size of and write int, just the data type. You can do this for all data types. So for writing this printf statement, there is no need of declaring a variable. The third one, when you're doing the last printf statement, you don't need to declare variables for the data types. You can continuously go ahead and just write size of int is equal to %lu, size of float is equal to %lu, and in the brackets just write size of int, size of float, size of char. You can go ahead and write. So this, for the first printf statement you need a variable. For the second printf statement you need a variable and a value, and this has got neither variable and neither a value. So these are three different cases where you can go ahead with printing the size of a data type or size of a variable associated with a particular data type. I'll show you all these three versions in code, so it will be, you will get a little familiar with how you can go about declaring all these. So we go ahead and declare variables for the different data types like int a, char b, float c, long d, double e. I'll just do 5 for now. You can keep on doing as much as you want. So I'll go ahead and printf size of a and %lu is the format specifier for printing size of operator, and comma, this is the function size of, and you have to put a inside it. So let's just print for 1. I'll put the operation hash include stdlib.h, the header file that is required, and let's go ahead and run the program. So size of a is 4. I'll change it to print size of lu is this many bytes, and we'll run again to see if it prints size of a is 4 bytes. Okay. So this is one way. I'll go ahead and do the copy pasting of the same set of statements for b. So size of b is size of b. Change both the places. This is c and this will be c. Size of d, and over here also d. So we are doing the part where we're using the name of the variables. So this is e and over here e. So I'll go ahead and run the program, and yes, it prints size of a is 4 bytes, 1 byte, 4 byte, 8 bytes and 8 bytes. Now I told you about values that you can use. You can use a is equal to 10 and character b is equal to, let's say, give a hash as the sign, it's single inverted commas, and float c is equal to, let's say, 12.3, long d is equal to, let's say, 6457, and double e is equal to 16.7543. If you run the program and it will still print, you can go ahead and put here percentage d. You can put for character percentage c, for float you can put percentage f, for long you can put percentage ld, and for this is percentage lf, and print the variables a comma size of that. So this is going to be b comma, this is c comma, this is d comma, and this is e comma. So printing the value as well as the size. So we go ahead with that. You will see you have the size of 10 is 4 bytes, size of hash is 1 byte, size of 12.300 is that 4 bytes, size of 6547 is 8 bytes, size of this is 8 bytes. So you can do in this manner. This is with the value as well as the size of operator. The next what I'd shown is you do not need a you do not need the variables at all. You can go ahead and write size of int. This is size of char, and this is size of float. This is size of double, and this is, sorry, this was long, not double. This was long and this was double. And in here, since you're not using a variable name, we don't need a variable value. We just can print out the size of operator directly. So take off all these, and inside the size of operator, go ahead and put in the data types. So this will be size of int. This will be size of char. This is size of float. This will be size of long, and this is size of double. So I'm writing the data type directly inside it. No variables are involved. Go ahead and press run, and yes, it shows size of int 4 bytes, char 1 byte, float 4 bytes, long 8 bytes, and double 8 bytes. So I've done 3 ways. One in which we use the variable name, one in which we use the variable name as well as a value assigned to it, and one in which we use just the data type, no values, no variables. In the variable name and the value, you can go ahead and write scanf statement, accept values from a user as well, and print the size. It'll all print the size irrespective of what value you give. A data type has got a fixed size, it will print that. Thank you.